We're moving on to adding and subtracting polynomials. So you are on the bottom of page 3, which we did some of yesterday. You'll finish it up today. It says that you add or subtract polynomials by combining like terms. Like terms have the same variables with the same exponents. So we'll start simple down here. Addition's the easiest way to go. When you have addition, these parentheses mean nothing. Now if there was a square here, the parentheses would mean a lot, but there's not. So in this case, these parentheses don't mean anything. And I had a couple of students ask last night, they were going back here to, I'll come back to it, about which ones they add and which ones they multiply and things like that. And the answer was you didn't, because they didn't match. So in this case, it says simplify, write each number in standard form. So what things match? Okay. Those are both x's to the first power. So I can combine those. 2x plus 3x. So sometimes you'll see people rewrite it as 2x plus 3x because they're grouping things that match. And then over here, we're going to add that to our other two, which is a -3 and a -9. Of course, when you add negative, it's the same thing as subtraction. So I combine these. How many x's do I have now? I have 5 x's. And -3 minus 9. -12. Notice again, we're going highest exponent order to lowest. And that comes into play here on this next one. So I got cubed here, and I got cubed here. But notice how they're kind of out of order. So the first thing I have to do is my highest degree, so that's my cube. So if I have 4x cubed and I minus 2x cubed, that leaves me with 2x cubed. I have a positive square, or a positive x there, -5x there. They combine to get -4x. And then -2 and 10 combine to get a +8. Okay, here are my b's. They cancel. 7b squared minus 7b squared, 0. So I don't have to worry about that. So they cancel off. Okay, I got a b here, a b here. They combine, they're both positive to get 20b. And then I got 12, -25, so that's -13, 12 minus 25. Or if you're going to use this addition side, 12 plus a -25 becomes subtraction. And the last example for addition. This one you got to be careful of. If things didn't cancel. In this case, the 7's cancel. So 7 and a -7. I was going to put the 7 down first. But in this case, our 7's cancel. +7, -7. Cancel. -5 plus 13. 8d. If there was any numbers left, they would go over here. But obviously, there's no numbers left because they canceled. Subtraction. Okay, I'm going to write up here. Your work is required on these, at least for day 1. I'm going to show you 2 ways to do these. Okay, but the biggest issue is that now the parentheses do mean something because we are subtracting a quantity. So one way to do this would be just to write down my 15r squared minus 8. But then this negative kind of distributes in here because I'm subtracting a quantity. So then I have my 10r squared, and this though becomes subtracting a negative. That becomes +12. So I'm subtracting everything in this quantity. So now that's one way to show your work. So now these combine, and now you might have some addition in here if things were both positive and you're combining like terms. even though it says subtraction up here. If they're both positive, like this 12, you're going to be adding that. But back to the r squared. 15r squared minus 10r squared. It's 5r squared. Negative 8 plus 12, positive 4. That's one way to do it. The other way to do it, and again, I want you to show your work on any subtraction ones. This negative, again, is going to flip all of these signs in here. But you could just write them underneath what matches, and then do it old school, up and down. So if I subtract negative 8a cubed, that actually becomes a positive 8a cubed. And then I'm subtracting 10a squared, so that just becomes subtract 10a squared. And then subtract a negative 9. So if I subtract a negative, that becomes a positive. So I have positive 9a. And I tried to line them up the best I could. My handwriting's not quite that small, but my a cubes match. I can't add an a cubed to an a squared, because if we go back to what we were saying up here, you have to have the same variables with the same exponents. So I can't add cubes to squares. I can't subtract cubes from squares. So I add them together, 16a cubed here. 5 minus 10, negative 5a squared, negative 2 plus 9, 7a. Going back to how I did the one above it, I'm going to take this negative, make sure I'm subtracting a w4, I'm subtracting 5w squared, but then I'm subtracting a negative 12, so that becomes positive. And now I start matching. Sometimes kids will do this, cross them off as they go. I hate that, because then you can't see what you crossed off. So I try to avoid crossing off. I'll do things like underline as I go. 6w to the 4th. I've seen kids, maybe if you're doing this pen and paper, using highlighters and highlighting different things. So they would go like here. Let's see, I don't really have a highlighter, but they would take this and color that, highlight that red and highlight this red, and then change their color and make this one green and this one green because they match. And then they do teal. Okay, or you could underline it, but obviously a highlighter you'd be able to see through. So back here, my W's. Negative 3w squared minus 5w squared is negative 8w squared. And then that leaves me with my 5 and 12 that combines to get 17. Okay, I'll try to zoom in here so I can line these up correctly. You have to be really careful on this one though. This is where the stacking doesn't necessarily work. If you look, I have an m cubed, but I don't have any m cubes over here. And I have an m squared over here. I don't have an m cubed over here. So if I was rewriting this, is probably the best way to do it. I have 0 m squareds. I have a negative 9m, and then I have 2. So I just wrote this in standard form, and I took care of this one already. I just rewrote it. And now we're going to subtract, so I'll change my color here, and this is the red side. So I'm going to subtract 2m, but look what I'm going to do. I'm going to line it up over here. So I took care of that one. I'm going to subtract negative 7m squared, so that becomes a positive 7m squared. Took care of that one. And I'm subtracting 5. And there's 0m cubes. So now we'll combine things. So that was a positive 0m cubed, I guess, if that's how you want to look at it. Or a negative, doesn't matter. M cubed plus 0m cubed is still just m cubed. Same thing here. 7m squared didn't have anything to combine with. Negative 9 and negative 2 combined to get negative 11m. And 2 minus 5 is negative 3. So again, if you're doing this stack method, you got to be careful that your terms line up. Pay attention to that problem there. This one was easier because you had a fourth, you had a 4 and a 4, you had a square and a square, you had a number and a number. They were in the correct order. If you notice over here, that's not standard form over here. So that's when you can kind of get thrown for a loop and maybe make some mistakes. So we did this yesterday. You should have done this. So somebody asked me on number 7, for example, all they wanted you to do was name each polynomial based on its degree and number of terms. So in this case, since this is a 4 and this is a 2, you can't combine them. Okay, same thing up here, a 3 and a 2, you can't combine them. So it's already in standard form. They were nice here. So the only thing we were worried about was the degree. So this one is a 4th degree, and it's 4th degree because of the 4 above the x. How many terms are there? 1, 2, 3, 4 terms. And if we're going to name it, well, then that's a quadratic polynomial. And then I think you always add in with 4 terms. So anyway, where are we doing? The 1 through 8 was yesterday. So today you are going 9 through 20. On page 5 and 6. That's it, guys. Have a good one.